Hello, and welcome to section 4 of statistical software packages for applied data analytics. I'm your TA, Ayush, and we've made quite some feat in the last 3 sessions. This session, we will be going back to how do we import the SUV data into RStudio for the third assignment, I believe, linear discriminant analysis or LDA, ANOVAs and ANCOVAs, which is analysis of variance and analysis of covariance. And finally, regressions, linear and logistic. I believe for the third assignment, we need to do logistic regressions. And before we run into RStudio, I just want to make sure that everybody is reading the primer that the professor, Dr. McDonald, has been putting on Blackboard. If not, I would highly suggest that you guys read the theory behind ANCOVAs, ANOVAs, linear discriminant analysis, and the logistic regression. So the R part would be much easier going forward. That being said, I will not be going over interpretations of any models, merely just how do we run RStudio. So I'm going to clean up my environment first. Right, so first thing we're going to learn is how do we import the SUV file. So we need the library Haven to do that. You get your current working directory. And I can see that that is not where my data file is. So I point out the directory where it is. So for example, I go to my files, desktop. I am already in my desktop. So let's go from the beginning. I want my desktop, my TA folder, week 3. And as you can see, that's where the assignment sits. So we need to tell R exactly where it is. So all you can do is just copy your path to your folder here, paste this, and just copy this over here, and you shall have the data set. So if I run this file, we can see the v3 file, SUV file is loaded into R. Beautiful. But unfortunately, I can't work on that today. So we're going to be using some other data sets. Well, first and foremost, I'm going to import my modules. So I'm going to need tidyverse for this assignment. So I import tidyverse and importing data. So for this, we're going to be using the iris dataset. But this is a good habit to know that in RStudio, if you run this data file or this data function, you can see all these variables are data sets available in RStudio. So for example, the friendly, GSV vocab, Ginsburg, many data sets. So for example, if you want to see this refugee appeals data, and we see the name is green, we can simply just say that our data, and we want to use the green data set. We hit that, and we can see, right? So all these data sets are quite nice if you want to just practice R or do your own analysis. But for this, we're going to be using the iris data set. So I want the iris. I run that, and I can see now I have 150 observations of 5 variables. Great. Right, so I'm going to attach the data. And let's get the summary statistics. Right, so we have sepal length, width, petal length and width, and species. We have 50 of Setosa, Veriscolor, and Virginica. Right, it will also be nice to see the structure of our data. So I call that, and we can see that is great that they are all in numeric variables, and we see 3 levels of factors here. Great. So we can run right into it with the first thing, which would be how to run an ANOVA, or analysis of variance. And I know we did this in last class too, but we can just get on with it and practice it one more time. So I want ANOVA 1, and I want to call out the AOV function for ANOVA, and I want to look at sepal length. Let's do that to sepal width plus petal length plus petal width. We need to also make sure to tell R what data set we're using. We're using data. Here we can see that successfully ran. And now if we get the summary of ANOVA, beautiful. So we can see that in relation to sepal length, sepal width, petal length, petal width are all or have some sort of an impact on petal length, as we can see clearly with these three asterisks, which specify that our p-values are less than 0.001, which means they're statistically very significant. Right. So ANCOVA, that was ANOVA, that was analysis of variance. And now if we want to check the analysis of covariance, we use an ANCOVA model. So for the ANCOVA model, we will need another library called CAR. And I would tell you why do we need a new library for this. So let's do ANCOVA 1. And we're still going to use the same AOV function. Actually, I'm just going to copy and paste it because it is absolutely the same. Right. So we have the same ANOVA model, but we're going to call it ANCOVA. But now, this is a big one. We're going to call out ANOVA, ANCOVA 1, and we're going to specify the error. For this, it's going to be a type 3 error, since it is an ANCOVA. Run this, and here we are. We have all the we have the summary statistics, and it's the outputs. And I did this because type 1 errors are not a problem when performing a simple ANOVA. But if you're trying to run an ANCOVA, type 1 errors will lead to wrong results. Hence, we need to specify to R that this is an ANCOVA and we need to use a type 3 error. Therefore, we need to use another function that is the ANCOVA, the ANOVA for the ANCOVA using the CAR library. I know this is a bit confusing, but you'll get a hang of it. And it's simply just looking for the type 3 error. It's pretty much it. And as you can see in our rows, the p-values and stuff, and we can always imply that these flowers have different proportions and are simply bigger or smaller because of sepal length, right? Great. So that's how you run an ANCOVA and an ANOVA. And remember, if you want to capture your outputs to Word files, something, so you do capture output, ANOVA 1, file, let's call it ANOVA.doc. So that has run, but now I need to find out where did it go. So I get my working directory and its users and I use. Therefore, I want my outputs to go to my week 4 folder. And where that folder is under my TA week 4. Again, I'm going to copy this. I should probably done that before. But nevertheless, we're going to go, you know what? We can just go to more and set this as a working directory. We just did. We just set the week 4 folder to my directory. Now I run this again. If I go to my v4 folder. Beautiful. We have our outputs right into a Word file. That would be quite easy if you are writing that paper to capture outputs directly in Word formats. Great. So now that we're done with ANOVAs and ANCOVAs, we can move on to a linear discriminant analysis. For this, we're going to get two new libraries. And I hope that it's making sense to do different models and to do different functions. These libraries are very important to know what to use at what point. So for linear discriminant analysis, we need two. We need psych and mass. Get these. Awesome. And running in linear discriminant analysis is quite simple. We just do LDA1. That is what I want to call it. You can call it whatever you want. So I want to do a linear discriminant analysis of species, because that is our class, right? That is our class, species. And I want to do it with everything. That means species and every other variable in the data with that little dot. And specify that data we're using is called data. Very original. We run this, we run LDA1, and hence we have our outputs. We have coefficients of our linear discriminants right here, proportions of trace, and the group means. Further, if you like to plot this, you can also plot LDA1. Here we go. So you can see your group means that are clustered here. So you can see from here, and the coefficients too. So we can see two clusters here and over here. Again, I'm not going to be going through the interpretation of the LDA because I believe the reading covers it very nicely, the primer on linear discriminant analysis that is available on Blackboard, posted by Dr. McDonald, obviously. Great. So now we can move on to a linear and logistic regression. For the linear regression, be quite simple. We can just do an LM1, and no library is needed here because RStudio already has that inbuilt. So we want to look at, let's do, sure, settle length, settle width, settle length, and petal width. Data we'll be using is still data. We'll run that. Invalid formula. Something wrong has happened here. I see what it is. There we go. So now we specified this is our dependent variable, and these are all our independent variables. This is the data set we used. That should be fine. It is. Now there's two things you can do. Obviously, you can do the summary. You get all the coefficients, etc., for your regressions. And obviously, you can do the capture outputs like this to get this table. Or if you want to be a bit more fancier, we can use Stargazer. And I believe we've been through this in our last class too. So we just want the LM1 type equals text. And if you want to save it, I can do out equals, again, LM1. Why not? I run that, and I can see the same table here, but in a much cleaner format. And if I go back to here, I look at my LM1, and now we have it over here. Oh, I'm sorry. I should probably do LM1 ... That would make more sense. So, should be fine. It is. Looks great. Awesome. And you can obviously look more into Stargazer by just doing a question mark, Stargazer, you can get all the necessary information. So there's many things you can do. You can apply coefficients, add lines, you know, anything really. Right, so that was linear regression. And now we can come out to the last topic, that is the logistic regression. And for the logistic regression, I will be using the Titanic data set. So I already have it here. So there's going to be two. There's a training data set, and then there's a test data set. So we have Titanic.train, and we have Titanic test. Great. Now we have a data section here. We can look at the head of Titanic train. Right, so we have passenger IDs, survived. This is what we're going to be classifying, the survive. P class, name, sex, age, and all these things. So to run a logistic regression, we're going to call this logit1. So instead of LM, now we're going to be using a GLM. So we're going to do GLM survived. And this is important because your dependent variable should be a binary variable, right? Do sex, P class, and age should be good. We do data equals Titanic train. And lastly, this is quite important. Now this is a logistic regression, so now we need to specify the family of the regression we're running, and that is a binomial regression. So I'm going to specify binomial, if I can spell it correctly. So right, that ran. So now we have a logit1. And similarly to all this, you can just call out the summary for logit1. Right, so we can see now we have the output from here. We can even call out Stargazer, and I don't know if any one of you have tried this yet, but you can also get both the models that you just ran. Right, so now you can see we have the logistic and we have the OLS, and you can compare them side by side if you wish to. I wouldn't be going over this. Right, so now that we have run our models and we want to get our predictions, because that's why we're running a regression, right? Because we want to predict how many of these people survived. 0 if they didn't, 1 if they did, I'm guessing. So we use predicted probabilities, that's what I'm calling it. We're going to use the predict function, logit1. Our new data is the train, and we want the response, the type. We run this, and we want to convert our predictions into zeros and ones. To do that, we simply say if else predicted probabilities should be more than or equal to 0.5, 1, or 0. You can run that. And to get a table of the predictions, it's also quite simple. We just run the table, the predictions, and the survived, because again, that's what a dependent variable is, and that's what we're interested in most, survived. We run this, and now if we call out the result table, This is a confusion matrix. Confusion matrix. So we can, from this, predict that 356 will survive, will not survive, so on and so forth. And it is important to look at these predictions because, well, to start off with, the table above shows the classes of a model predicted versus the true values of the survived variable. And right, this is a confusion matrix, and I feel like this should be a good place to end. Now that we have covered how do we get the predictions from our logistic regressions, we have covered linear regressions, LDA, linear discriminant analysis, ANCOVAs, ANOVAs, and importantly, getting your data set into RStudio using the Haven package and importing our SAV data. Thank you so much for sitting through this, and I hope this was helpful. If there are any questions, I would be happy to, set up a Zoom meeting, or you can always email me any questions you have. Thank you so much, and good luck on the third assignment. Bye-bye.